Okay, so welcome back. We are going to talk about a new method of solving linear equations, and this is sort of a way that can sort of help you both now with algebra, your Algebra 2 course, or just in the future when it comes to fractions and computations involving fractions and mixed numbers and things like this. Sometimes it's often useful, it's very useful to clear the denominators. That way, when you clear the denominators, you're left with just whole integers, and just basically the fractions disappear. That's a good thing. So how do we solve linear equations by clearing the denominator? Okay, so let's look at this problem here. Number one, we have x over 3 minus 8 is equal to 1. All right, and now my goal, obviously, when I'm solving linear equations, first and foremost, is to get x by itself and everything else on the other side. All right, so maybe a lot of you would start this equation by adding 8 to both sides, but we can do that for sure, but I'm actually going to show you how to clear the denominator first and foremost. So what I'm going to do is I'm literally going to take the entire equation and multiply everything by 3. I chose 3 because if you look in the denominator here, we have a 3 here. That's why I'm multiplying by 3. That's because if I have something, let's say x, right, over 3, and I multiply by 3, well, that's the same as 3x over 3, and that just simplifies to x. So that's exactly what's going to happen here, right? I'm going to take 3, I'm going to multiply by x over 3, then I'm going to multiply by negative 8, and multiply by 1. So I'm going to rewrite this equation now that I've multiplied everything by 3. Of course, starting from the left, x over 3 times 3 is just going to be x, as you can see by my computation above. And then minus, because it's negative 8, negative 8 times 3 is negative 24. And then 1 times 3, of course, is just 3. Last step, I just need to add 24 to both sides. So x is equal to 27. Okay. So maybe that looks a little more complicated, but bear with me. I overcomplicated a simple problem for a good reason. Okay. This is actually cut off here. So let me actually clear this up. Bear with me, please. All right. So this is a 2. All right, so now in the next equation, we can see that, like, all right, now we're running into some issues here. It's not going to be so easy to solve for x here. So in this case, I'm actually going to clear the denominator. It's actually it's going to make things way easier. All right, so when you look at this equation, we have x plus 1 over 5 minus x over 10 is equal to 2. Okay, and how do you decide what number to multiply throughout the whole equation to clear everything? Well, you want to think of the lowest common multiple, the LCM of the denominators. So of this and this. Well, the LCM here, the lowest common multiple of 5 and 10, happens to just be 10, thankfully, right? So because 10 is a multiple of 5, so that's it. So I'm gonna multiply by 10. I'm going to multiply everything in this equation by 10, and then I'll be left with no denominators, no fractions. All right, so I'm going to multiply this by 10, multiply this by 10, and multiply this by 10. So I literally take all of my terms, and I'm going to multiply by 10. On the left side, we have, so you can this is actually a huge point, which I think a lot of students sort of misunderstand. When we have this, we have 10 times x plus 1 over 5, and the question is, what do I do? Well, the point of clearing denominators is to literally get rid of it. So I'm not going to distribute the 10 first. I'm actually going to get rid of 10 and 5 by simplifying it. Well, 10 divided by 5, that's just equal to 2, right? So I'm left with 2 times x plus 1. That's what's in the numerator, right? I literally just took 10 and I divided it by 5, and that gave me 2. Now what about over here? We have 10 divided by 10. Well, that's just 1. So I'm left with just x. So on the left side, I've computed, I have 2 times x plus 1 minus x is equal to 2 times 10, 20. Okay, from this point, I need to actually distribute my 2 into this parentheses. So I end up with 2x plus 2, right? And just 2 times x and 2 times 1 minus x is equal to 20. I'm going to combine my x's now. 2x minus x is x, and I'm going to subtract my 2 over. X is equal to 18. There we go. Okay. So now the hardest problem. All right, so now I've thrown a curveball because I kind of cheated a little bit, because in the first 2 problems, the LCM happened to be one of the denominators. So in the first case, the denominator was 3, and secretly there's a 1 under here for the 8. Well, the lowest common multiple of 1 and 3 is of course 3. So that's 1. 3 was the lowest common multiple of these 2 numbers. In the second equation, we have 5 and 10. The LCM, of course, is 10, as we found. In this case, it's going to be neither of them, okay? And the reason for that is sort of, well, I'll leave you to think about why the lowest common multiple is not 5 or 3. But we do need to find it still. So the LCM, the lowest common multiple, I will quickly just run through how to find the LCM. We write down multiples of each of the numbers. Remember, I'm using the denominators here. And you just find the lowest number, which are the same in each multiple. So for 3, we have 3, 6, 9, 12, 15, etc., etc. And then for 5, we have 5, 10, 15. And I can stop there because I have 15 and 15. So 15 is the LCM of 2, 3, and 5. So I'm going to use 15 to multiply everything out. And the reason I'm doing that again is because I want to clear that denominator. Okay. So I'm going to rewrite my equations, but now with 15. So we have 2 times x plus 3 over 3. And it's going to be multiplying. I'm going to multiply by 15. I'm also going to do the same with the second term. So I take 15 times x minus 1 over 5. And that's going to equal to 1/3 times 15, which is 15 over 3, or 15/3, right? Okay, so now I'm going to do some simplification here. At this point, when you see something like this, it's really up to you how you want to simplify things. You have to understand that multiplication is commutative, and commutative means you could do it in any order. Notice I'm saying that, and there is a parentheses here with addition, right? And same thing over here with subtraction, right? We think that like, okay, there's some sort of order, but it's not the case because we actually have those parentheses there. It's signifying multiplication. So I can do everything on the outside in any order I like. So when it comes to 15 times 2 over 3, I could choose to multiply 15 and 2, but I'm actually gonna, I'll show you that you can actually, in a future video, how you can sort of manipulate numbers to your advantage. So I guess actually I will just multiply 15 times 2. 15 times 2 is 30 over 3. And then minus 15 over x minus 1 over 5 is equal to 15 over 3. All right. Well, 30 divided by 3. Once again, you can do this because multiplication is commutative. So 30 divided by 3 is just 10. X plus 3 minus 15 divided by 5 is 3. And if 15 divided by 5 is 3, that means 15 divided by 3 is 5. Okay, so now we've gotten rid of our denominators, and now we have a much simpler linear equation to solve. I just need to multiply this front term out to these quantities. So 10 times x, starting from the left, plus 10 times 3, which is 30. And then here, on the second term, when I distribute, I'm not distributing 3, I'm distributing negative 3. So minus 3x, and then negative 3 times minus 1 is plus 3. And that's going to equal 5. All right, now I have to just combine my x's, and get everything else on the other side. 10x minus 3x is 7x. 30 plus 3 is 33. So I'm going to subtract 33 from 5. And so 7x is equal to, well, 33 minus, so I can actually subtract 3 from 33, which is 30. Subtract 2, 28. So I have negative 28 on this side. And so x is going to equal to negative 28 divided by 7, which is just negative 4. Hope this helps.